This is Dr. Fox. Let's talk about the internal ear. In this video, we'll discuss the structures and functions of the internal or inner ear. Internal ear is encapsulated by the petrous part of the temporal bone. It has two major functions: to help modulate equilibrium, i.e. balance, and to help modulate audition, i.e. hearing. The equilibrium and balance are the purview of the vestibule as well as the semicircular canals, whereas audition or hearing is the purview of the cochlea. There is an internal auditory meatus in the temporal bone through which both cranial nerves 7, the facial nerve, and 8, the vestibulocochlear nerve, travel, and it is cranial nerve 8, the vestibulocochlear nerve, which is going to serve the inner ear. The structure of the inner ear is rather complex, and there are many intricacies to this and granular details, many of which we will not entertain as part of this course, but suffice it to say, there is a bony labyrinth and a membranous labyrinth. That bony labyrinth is dense bone within the petrous part of the temporal bone. It's more dense than the petrous part, and so bone of the petrous part may be mechanically removed, and the bony labyrinth may be dissected away in the laboratory. The bony labyrinth is lined by a periosteum, and it contains a perilymph fluid. Now, deep to this is the membranous labyrinth, and that membranous labyrinth contains an endolymph fluid. So let's take a look at some of these structures in greater detail. So let's start here with the oval window. The oval window is one of two communications between the middle and inner ears, the other being the round window here. So as you recall, the footplate of the stapes sits on that oval window, and sound vibrations are going to enter into the inner ear. So here we have the vestibule. The vestibule is the central part of the inner ear, and it contains two membranous sacs, a utricle and a saccule. The utricle and the saccule are going to be important for linear acceleration. So there are specialized receptors in there that are able to communicate to the remainder of the CNS what the head is doing in three-dimensional space, what position it's in or moving into. Coming off of the vestibule are three semicircular ducts, so these are at 90 degrees to one another. There is an anterior semicircular duct, there is a lateral semicircular duct, and then there is a posterior semicircular duct, so that one may detect angular acceleration in any of the three dimensions. So we know which way our head is accelerating or dynamically moving at any given time. So the semicircular ducts and the vestibule work together for maintaining equilibrium, and that allows us to have balance. So audition, or hearing, is the purview of the cochlea, this snail-shaped organ here. So there are layers to this, so there are both bony and membranous layers to it, and so there are fluid canals of both perilymph and endolymph throughout this structure. And so as sound waves move in, they're able to vibrate the perilymph and vibrate the endolymph. And there are specialized hair cells within which are very susceptible to danger from greatly amplified sound. And because fluid is incompressible, we also have from the oval window, we also have a round window out that has a secondary tympanic membrane on it that is going to vibrate to accommodate the expansion of the perilymph throughout the cochlea. So this is the very basics of the inner ear. This isn't something that we will see in great detail in the laboratory, but you will have an opportunity to work with an ear model that has a part of an inner ear to it to examine these structures and their relationships to one another. And that leads us to the assessment question of the video, and that is, which structure of the inner ear directly communicates with the middle ear? Is it the cochlea? Is it the semicircular canals? Or is it the vestibule? Well, semicircular canals communicate with the vestibule, and it really comes down to what one means by directly communicates, because the cochlea has a round window and the vestibule has the oval window. Both are communications between the middle and the inner ear. The better answer would be the vestibule, because the vestibule is what is conducting the sound vibrational energy from the ossicles to the cochlea, whereas the cochlea just has the round window, which is vibrating to accommodate the incompressibility of the perilymph. So best answer vestibule, but one may make a case for cochlea also being technically correct. Anyhow, thank you so much for your time, and I look forward to seeing you in the laboratory. Take care, everyone.